Data centers spend millions of dollars and billions of gallons of water every year on a single task, throwing heat into the sky. Meanwhile, a typical home in a cold climate burns natural gas or oil just to generate that exact same thermal energy. At a hardware level, a computer processor doesn't consume energy to arrange bits. It converts electrical energy into thermal energy while performing calculations. Every single watt drawn by a server exits as heat. We pay once to power the computers, again to chill them, and a third time to heat our living spaces. The identical joule of energy is treated as a toxic waste product in one building and a premium utility in the next. Waste is a property of where the observer draws the boundary around a system. A data center's heat is waste because the boundary isolates it from homes that need it. Redraw the line to include them, and dynamics change. Instead of piping heat miles away, move the compute into the dwelling. The server rack becomes the central heating system. This is a 2026 reality. By running liquid-cooled nodes tied into domestic plumbing, the house stops being a consumer and becomes an earning node. Redrawing the boundary around a single chip changes the role of the house within the network. The foundational unit is the GPU boiler. It is a physical appliance where a liquid-cooled AI server takes the place of a traditional gas burner. Cold water enters the system, passes directly over the working processors, and exits at 65 degrees Celsius, ready for the shower, the dishwasher, or the radiators. The same kilowatt-hour that executes sellable AI inference also heats the home. One unit of energy performs two distinct economic jobs. This eliminates an expensive and wasteful step from the process without requiring a scientific breakthrough. To power these nodes, the home requires its own generation. Rooftop solar arrays act as the primary power plant. Energy storage is handled in the driveway. Bidirectional charging allows an electric vehicle to power the entire house during the night. Potable water follows a redundant logic. Solar-powered atmospheric hydro panels pull emergency drinking water from the air, providing a supply that works even when the aquifer or the pumps fail. Food production moves into the basement. Automated hydroponic units use precisely tuned LED lighting to grow crops year-round, using 90% less water than soil agriculture. The thermal loop interlocks these systems. Waste heat from the GPU boiler is piped downward into the basement to maintain growing temperatures for the hydroponic crops during the winter. Midday solar surplus is directed to power the grow lights and run extra intensive AI computations. Organic plant waste from the hydroponic farm is fed into a biogas digester, creating methane to back up the kitchen's cooking supply. A local AI manages this resource balance. It acts as the house's nervous system, watching energy levels and hydroponic health without relying on the cloud. When the system is idle, the AI securely sells spare computational power to decentralized networks, earning passive income for the household. Each subsystem's output is the input for the next, creating a closed loop achieving domestic autonomy. When these homes are connected by fiber optic lines and microgrids, the perspective shifts from a single plot to an entire neighborhood. Centralized grids are mathematically fragile. A single failure at a substation can cause a regional blackout. In a decentralized network, any healthy node can share its surplus power, heat, and compute to keep the surrounding collective alive. Interconnected autonomous homes function as a distributed power plant, as a local data center, and an underground farm. This transition follows the arithmetic of systemic resilience, moving from a single point of failure toward a network where any healthy node protects the whole. This decentralized system has one clear requirement: the residents must maintain and service their own hardware. By taking on this responsibility, a family reverses the financial identity of their home. Historically, the house has been a liability, a box that continuously drains cash for utilities, heating, and taxes. Redrawing the boundaries turns the home into a self-sustaining asset. It pays its own bills simply by existing, computing, and sharing surplus with the network. The future of global infrastructure is currently hiding inside the walls of the residential home.